So for an example of linear approximation, we'll say, what's 64.1, say, to the 1/3 power approximately equal to? Now I'm going to carry this out in this new notation here. The function involved is x to the 1/3, and then its differential, dy. Now I want to use this rule to get you used to it, because this is what we're going to be doing all of today, is we're differentiating or taking the differential of y. So that is going to be just the derivative. That's 1/3 x to the minus 2/3 dx. And now I'm just going to fill in exactly what this is. At x equals 64, which is the natural place to close by where it's easy to do the evaluations, we have y is equal to 64 to the 1/3, which is just 4. And how about dy? Well, so this is a little bit more complicated. Put it over here. So dy is 1/3 times 64 to the minus 2/3 dx. And that is 1/3 times 1/16 dx, which is 1/48 dx. And now I'm going to work out what 64 to the whatever it is here, this strange fraction. I just want to be very careful to explain to you one more thing, which is that we're using x is equal to 64, and so we're thinking of x plus dx is going to be 64.1. All right? So that means that dx is going to be 1/10. All right, so that's the increment that we're interested in. And now I can carry out the approximation. The approximation says that 64.1 to the 1/3 is, well, it's approximately what I'm going to call y plus dy. Because really the dy that I'm determining here is determined by this linear relation. dy is equal to 1/48 dx. And so this is only approximately true, because what's really true is that this is equal to y plus delta y in our previous notation. So this is in disguise, what this is equal to, and that's only approximately equal to what the linear approximation would give you. So really, even though I wrote dy as this increment here, what it really is, if dx is exactly that, is it's the amount that you would go up if you went straight up the tangent line. So I'm not going to do that, because that's not what people write, and that's not even what they think. Right? They're really thinking of both dx and dy as being infinitesimally small. And here we're going to the finite level and doing it. So this is just something you have to live with, is a little ambiguity in this notation. All right, so this is the approximation, and now I can just calculate these numbers here. Y at this value is 4, and dy, as I said, is 1/48 dx, and that turns out to be 4 plus 1/480, because dx is 1/10, so that's approximately 4.002, and that's our approximation.